Okay, so let's start today's discussion by the time others join. So this week, mostly, so this week, this is the 11th week of Explores Operational Planning of Coordination System, and which is hosted and this is Sandeep Ganguly from IIT Guwahati. And as we already have seen in the last week and the previous weeks, that this is mostly driven towards the distribution system, the distribution side. So the current scenario or current status of the distribution system is mostly dominated by the distribution side. In the distribution side, we mostly see the presence of the distributed energy resources. So, with the presence of distributed energy resources, the problem and the solution, all these things are arising. So, what is the problem? If we may see that the problem is with the distributed energy resources in the grid, so there's a lot of intermittency, lot of intermittency is being faced. And the advantage is that this is the disadvantage, let me say, or limitation also, disadvantage. They, both of them are similar. So, And what's these limitations would result in more system awareness, or we may say the more awareness should be delivered by the operators, because it has a lot of intermittency. So when the system has a lot of intermittency, so the the performance that was previously in place, so those performance will now become a bit different because the system would deliver something new. And what is the new, or what new feature will it aid? We also don't know, because the intermittencies are not priorly known. Although we have forecasts, but still we have at least few issues regarding this presence of intermittency and the forecasting accuracy. Although these are becoming better nowadays, but it's not up to the mark so that it can accurately predict. So with the presence of such intermittencies, although the advantage is that the we are switching more towards the greener energy usage, and that would result, or that would the minimize the usage of conventional energy resources. So the uh, and due to this, in this week, what we have seen is that system, or the distribution systems, are much prone to observe much topological or large topological changes. And these topological changes, as we all know that nowadays the distribution system operators are present. Okay. So distribution, distribution system changes, or we may say the topological changes, in some cases several configuration, or we may say topological modifications. And to perform these topological modifications, already we have seen in the week's lecture that it has the presence of sectionalizing switches, tie switches. Okay. So sectionalizing switches and tie switches. The performance of using both the sectionalizing and tie switches, the demonstration has been shown in a distribution test figure. And what we have observed is that due to the we are to minimize the power loss at a point of time, as well as to enhance the reliability of the system. So what we are aiming is that we are trying to minimize the power loss as well as improving the reliability. So being this the aim of the operator, so the possible reconfigurations are tested. Okay. And based on that, some results have been obtained where the power loss optimal reconfiguration of the network. So we have to find out the optimal network or reconfigured optimal network configuration. Right. So these may be one of them is power loss needs to be minimized. The next one can be voltage improvement, reliability already I've reliability enhancement, and security. So these are the major optimality, means the features that should be ensured so as to attain the optimal network configuration. So this is mainly optimization problem, to find out the optimality, and the optimal minimization or optimal problem for network configuration may be subject to some constraints as well. So the constraints that can be taken into consideration with the objectives might be as detailed can be observed. So subject to various constraints as well. So the constraints can be with the power balance constraints, bus voltage constraints. So these type of constraint needs to be ensured with the reliability and power loss minimization, security enhancement, so that the system performance is within the tolerance limit, and all the network parameters are within the set point, network values are within the set point limits. So after performing various the combinational or the optimization approaches, so mostly as Sir has already detailed about the optimization approaches based on the, you may say, the multi-objective optimization problem based on the genetic algorithms, PSO, means the meta-heuristic type approaches. So there are heuristic, meta-heuristic, as well as mathematical approaches. So in which some examples are also shown where the outputs or the losses that has been obtained based on the configuration that has been demonstrated, and the papers that were delivered uh, or consulted, so references can be seen. So overall, the reconfiguration part, as we may see the algorithm, how the algorithm works and Pareto-based approaches. So overall, this the need or the we may say the need of this distribution system reconfiguration problem to be ensured, we have to have various things in mind, right? So these can be hybrid approaches also can be taken into consideration. So and with the considering these DERs, so these problems are mostly discussed with the DERs in place because the DERs are the main or the root cause of such deconfiguration or multiple deconfiguration. So we are to minimize the power loss as already have discussed, and based on that few reconfigurations topologies are being obtained as the result, and based on those topologies, power flows. So then for those cases, the system would definitely work well. So this was mostly the part, you may say the first part or module, and on the other side, the second two lecture, well, this was first, and for the second two or the other two lectures, so here that was mostly driven towards the presence of distributed energy resources, DERs, or DGs, or distributed generation. So nowadays DERs are being generally uh, used, not DGs, because these are sometimes not the generations only, right? So the batteries are not generators, but they are also delivering power. So this may be considered or coined as the resources so as to better highlight or to make it much more generic. So DER, using DER is giving a much more, we may say, diversity to include various DGs, types of DGs or DES. Okay, so generating sources or power generating resources. So, some types of there are the definitions that was first published in the EPSR journal that has been also discussed. So this includes the PV, solar photovoltaics, solar, wind, geothermal, etc., biomass, etc. So what we may see is that some limits on the capacity has also been discussed. So based on the limits or the capacities of these distributed energy resources, they are being classified on the basis of the generation capacity, right? So when we take into consideration that these resources can deliver power to the grid as well as they can take the power as the requirement, they can store the power among the excess power. So in overall, we may say that things can be made much more dynamic in place, right? So there are the provisions of including the grid connected or so these two provisions allows us to have multiple types of connectivity. And when coming to the distribution side, since distribution sides, in the distribution side, we need to deliver power to the customers, right? So customers are our main objective to deliver power to the customers. So when we have these standalone systems or grid connected mode of operation too, but mostly we have the provision to take the or deliver the power to the customers from these resources. So we should definitely go for that. And that helps us to a very interesting point. So the point is also known as the point of common coupling. So this is a very simple term, but this is also a very hefty term as well, right? So when we use the term PCC, this sounds very easy and simple, but the functioning at the PCC is very tough when we consider various modes of operation of switching. So that inherent operational features or behavioral patterns in the form of operation can be controlled. So to properly monitor the PCC, systems needs to have better control features or control actions developed. Okay. So previously what we learned or we may consider the passive distribution system. So you said the previous one, passive distribution system, but now with the inclusion of the DERs, this is now known as active distribution system. So this is now known as active distribution system, and the distribution management system needs to be properly, or we may say ADMS. Advanced distribution ADMS is a very well known term, ADMS. So that needs to be properly developed so that better operation and control techniques can be delivered. So in the passive distribution system, there is no, or you may say there is an absence of these DERs, but with the inclusivity of these DERs, systems have become active, and is also known as the fundamental point of adding, or although this being definitely including much dynamics in the system, so why are we transitioning to these forms, right? So advantage, the basic advantage is that we are aiming for the go green uh, theme. So when we move towards the go green theme, so we'll have to have the provision of maintaining the minimal usage of the conventional energy resources. And for that, we need to include, although these are cost active, we are investing money to the present in the present scenario, but at least to get better outcomes in future. So, so the benefits can be in the form of cost, okay, and control techniques can also be governed by the coordinated operation, because when the systems are in a much larger scale, so, and also distributed somewhere, and this distribution as the transmission system we need to monitor smaller, but when we come to distribution side, the number of nodes becomes very high, and the measurements that are available are very low. So proper scheme needs to be developed. So this entire thing requires a proper communication infrastructure. So with the current form of renewable energy penetration, we may we have some terms or the equation which delivers delivers us the information of how much renewable penetration is in place. So there are two types of this. One is average penetration, and the other one is instantaneous. So and similarly for the instantaneous penetration, so this overall information states the advantage of of having the average penetration of the renewables to the instantaneous penetration of the renewables. So when we have these two types of information, so we'll have to have the information of at a point of time when system this is relevant in the form of billing exercise. This is much more relevant in the form of operation or control strategy. So these two segments is because this will show or we may see some advantage from the billing exercise because the energy information that we have at the current point of time. So that will also aid in the form of our bill to reduce somehow and somewhat the bills would be reduced or the cost or the amount that will reflect in our bills would reduce. From the instantaneous penetration point of view of the renewables, the operational control strategies will be much more uh, relevant because as we need to predict, or we rather it's not correct to say predict, we need to accurately monitor the states. And when we have the, or when we are to monitor the states, so we'll have the at least have the infrastructure to monitor them, but based on their instantaneous value. Because if there are problems being arise in a current time frame, so that we should address at that point of time, not by doing at the end of the day, because the energy information is collected per day wise. Okay? So the easy or we may say the advantage that it provides the advantage of these smooth transitioning towards the DER integrated power systems or distribution systems, we may say, in the current time frame, as per the relevance of the course is concerned. So we may see that the It's easy, or we may say the plug and play feature is already prevalent. The other one is active or reactive power support, we may say. Some fault ride through properties as well, because at many point of time, the due to system operation, the control or the controller might think that, or not only think, because it works on the information or the data that it has received. So based on the data, some DR intermittencies may come in the context of fault, because sudden abrupt changes might be treated as fault. But in those cases, we need to just look over that whether this is persisting for a longer period of time. So time frame comes in question, right? And on the basis of that, the judgment of the person or the operating personnel who is in the substation or in the control center, so they can detect. Although nowadays these things are not done in person, because the devices that are built, they only perform all these actions. The decision making capability of the devices are much higher. So overall, all these aspects leads to a better improving the power quality of the customers, you may say, but user is much more better term rather than customers. So users may be all types of users, means industrial, commercial, and domestic. So yes, this is the part. So based on that, already we have seen that the hosting capacity of these EERs enables the users to have a better understanding that whether the current situation or current configuration would allow uh, infusion of much higher resources, or whether the current resources or current distributed energy resources that we are currently using or that is already been integrated in the system, is that enough? Because we have already, if someone has any provision to enlarge their areas of premises, given that their land all these things like land, property, all these things, and if they have the provision to enlarge their property or their wealth, so they will definitely try to do so if it is in the official path as well, considering that all these things are done officially. So considering all these factors, the when we have the possibility or the provision to include number or the DER capacities in the current topology of the distribution system, so we'll definitely go for that, right? And doing so would result in better power losses, to minimize the power losses, and for that the customers will also benefit. And as we are as the major goal of the entire current time frame is to uh, move towards net zero, so that will also help in a better outcome. But the decision on the basis of which these things can be done, so we have to have some metrics, right? So the metric that is generally used is on the y-axis, the reliability, we may say the reliability step. So reliability or power loss, and on the x-axis, we generally keep the DER or DG value, right? So the DG value in the sense DG power that can be injected. Okay. So and suppose we have some graph, like let's have some graph. Means this is random, I've drawn a random graph. So from this graph, what we can understand is that since this is the minimal point, okay. So considering power loss, if this is the minimal point, then we'll go for this, right? So this value of dg, if we integrate this current value of dg power, means this is in megawatt, let's say, or hundreds of kilowatts. Okay. So if this value is integrated to the grid, to the system, distribution system under consideration, so that will not affect, or this is the maximum that we can go. So suppose if we are working or operating in some DG value, which is suppose let's say this one. So we have the provision to increase this much. Okay. So these things needs to not, but the judgment, these judgment can be made based on the power losses, right? And we have some limiting characteristics as well. So when we have, uh, considering the case that has been discussed by professor, so what he has shown in his slides also, that when we integrate for individual node in the distribution system of IEEE, or not, it's not IEEE, I guess, it's standard 33 node distribution, radial distribution feeder. So there you have seen multiple graphs or multiple plots which follows kind of same pattern. That is, first it's going down, and then after a point of time it's going up. So there is an optimal point for each of these voltage values, or the loss value, sorry, not the voltage values. So the power loss of this entire, considering DG at each node of the standard 33 node distribution, radial distribution feeder, we can observe that at each point of time, at each point of these minimal value that is obtained for individual graphs, and a single minimal value of Gg will be obtained. And if we consider that value in practical test cases or practical situations, we will see that up to a certain point, up to that point, it gradually decreases and then it increases. So we can conclude that if we consider that minimal value, so that will allow us to integrate much more DG, considering the upper sides of the on both the sides, which upper part on both the left half of the midpoint and the right half of the midpoint. And not the midpoint, I should say it's minimal point, because midpoint is all the optimal point. Okay. So the judgment is generally made based on the losses. Okay. And based on that DG power characteristics we try to assure. Okay. So this was mostly of the DG part that has been discussed in this week. And coming to the other segment, which is now a hot topic in the current research domain as well, is the microgrids. Although a lot of work has already been done, but what we have seen is that the various form of microgrids are now getting uh, greater prominence as that of the previous ones. Okay, because these microgrids have several advantages. So one of these advantages is that it improves efficiency improvement, considering the renewable or the thermal energy storage, thermal plants in place. So we can limit the usage of those thermal plants, okay, and improve the power quality as well. Also, we have the provision of voltage control feature. So, considering the microgrids, so financially, or you may say financially it's a stable form, and operation or investment wise also it is helping somehow because suppose we have a distribution system comprising of this is let's say this is the substation, okay, this is the substation and this is the distribution area. So from the substation we have the main transmitter, and from the transmitter we have number of nodes here and there, and laterals, these are the laterals, and considering these as the laterals we have loads connected here and there, and system may be considered unbalanced too because distribution system is generally unbalanced, but just a demonstration test case as I'm detailing here, so let's keep it simple. So considering this, and this being the substation, so when this is on the distribution side, but when this is distribution side, let's say this is the transmission section and this is the generating section. So when we are setting up the microgrids, the advantage is that the power, they are now this is the point. This can be considered as the point of common coupling. Okay. This can be considered as a point of common coupling because if the if the substation gets disconnected from the load side, this is the load side we may say, and let's say we have DGs in place, which may be solar, wind, etc. Let's suppose these are the test case, all these are. So if we disconnect the substation from the load side, so what we can observe is that we have a provision of the DGs feeding power to the loads, right? And that is the advantage because we are supremely omitting this transmission cost. This is a major segment of the cost that is already we know that these generating plants are much away from the customer premises or the domestic areas. Okay, so what we do is that we generate power somewhere which is near the for the conventional power plants I'm discussing. So we generate power far away from the local areas. So based on that, as we generate power, so we need to transmit to the load center as well. Instead, if we have those features or the DGs in place or the DERs in place, which can accommodate the deficit or the demand of power in this area, so that will reduce this transmission cost, right? And reducing this transmission cost and the cost, this is also going from the customers itself. This the government and the companies, private entities won't pay this amount of or this uh, power carrying cost that would be charged by the transmission operators or the transport. So this has to be borne by the customers only. So if the customer and since the power is to be delivered here, so if we can have the load center and the power can be delivered there itself, so that's a better feature. So that leads to the development or that's the uh, advent of the microgrids. That's how the advent of microgrids took place. So this is there are two segments where it is grid connected or islanded mode of operation. But the major problem here is that the sudden, since mostly these are governed by the renewables, so sudden high demand can't be met. So that is a major issue, and for that we have the feature. We generally keep this feature of this islanded and disconnected mode of operation. So whenever this islanded system would not deliver the requirement, So in those cases, systems can be made different, and deficit of power can be demand, or deficit of demand can be uh, taken from the transmission or distribution. But at least we have tried to reduce the power consumption, and based on this reduction, we have saved much amount of cost as well. But the current framework, these DERs are highly intermittent. So already we have discussed previously the intermittency plays a major role here. The low energy values or the energy generating capacity, and the most important thing is the unavailability of the communication infrastructure. So this is a major challenge at present because conditioning to the smaller areas, if there are some few years back also, some works have also been proposed where uh, microgrids will have microgrid central controller, and individual uh, microgrid areas will have mini controllers. But the information will flow from the microgrid central controller MCC to the mini controller, and accordingly the control actions will be delivered to the equipment sites. Okay. So these things are making a bit system difficult at the very point of time because designing controllers as the types of infrastructure required. So this infrastructure or the communication infrastructure, if we try to involve or incorporate, these communication infrastructure will be probable of or much prone to various kinds of malicious system attacks, right? Because this would not be the security that can be delivered at these microwave level can't be the same as that of the transmission level or at the distribution control center level, right? Because that would again incorporate cost or inherit these costs to accommodate the cost associated. Individually, the customers have to bear those costs as well. So we are trying to minimize the costs, and in, in a way, we are again inducing those costs to or incurring those costs to somehow or the other. But this is the primary aim, but still some operational or infrastructure, communication infrastructures are being developed, but not up to the mark as well as that of the transmission or the distribution. So, so efficient planning needs to be framed. Efficient planning needs to be governed, and considering the microgrids in operation, the types or the microgrid component, microgrid components can be in the form of small DERs, we may say low voltage networks, the MCC as previously detailed, and the mini controller, mini controller. So these components needs to be ensured, right? The function of the central controller is to include the energy management system modules and accordingly perform or the bidirectional information and power flow needs to be ensured and the decision has to be taken by the central controller. But and accordingly those information would be delivered to the mini controller, load controller, and the system would perform. But protection aspect also needs to be properly taken care of because considering the microgrid, the protection uh, aspect needs to be developed as well. On the other hand, we have some potential provision to include the, you may say, as the protection also, because sometimes fault right through situations as already discussed in the other part as well, in the, considering the distribution side of the distribution systems. In the microgrid systems are much more prone to these types of random activities for which the system not much not, or the controllers or the operators are not that much well prepared. So the parts of the microgrids can be in the form of wind, solar. So in this week, only wind has been discussed. So we will restrict up to wind not only because after that solar will be taken up in the next week, the upcoming week. So in the wind, it has two types of wind features, or the horizontal type and the vertical axis type. And the wind mainly works on the principle of Betts principle, and the other part of this is that types of wind turbine, which include the synchronous generator type, DC generator type. Although these the synchronous DC generator is not at all used nowadays, DC generator type, the type which is used, induction generator type, but the most used is DFIG. So DFIG is doubly fed induction generator. And the other one is PMSG, is permanent magnet. So these two are mostly used, but this DFIG delivers better advantages in the form of control features, where it has two types of one, the stator side directly feeds power to the grid, whereas the rotor side also, from both the sides, it also delivers power to the grid via bidirectional converter. Okay, so from the stator to grid, from the rotor, which is the rotor side to grid. But here converters are bidirectional converters are in place, and these bidirectional converters allows the coupling and control, better control feature. Also in the permanent magnet, the permanent magnet is already from the name it suggests it's the permanent magnet. So the magnetic field needs to be uh, we have the designer or the controller operator doesn't have any control over the of controlling the magnetic field. So permanent magnet has some disadvantages that the cost. The current in the current framework, PMSG wind turbines are not mostly used because somehow uh, we may say it is in the form of in the current context as well. China has the most or the only resource of this paramagnetic comes from China. Okay, so and otherwise, since if the generators are being taken from China, So in the other countries, if we try to use them, so we cannot have we don't have the capability to have our own resource. Okay, in the EV batteries as well, because so the machine axis or the machine magnetic field concentration is also enhanced in various other ways rather than emphasizing on the permanent magnet type, because once it is being incorporated or inherited from China, you can't replace them as a whole, because and for each of the fault or some issues, you will have to incorporate or you have to connect directly to those people who are producing it, right? We don't have the capability to generate on our own, or to produce on our own, because we don't have the resource. Okay. So that is the overall thing. So for that, DFIG is used, and on the vertical axis, the axis is vertically mounted, not horizontally. Vertically mounted in the vertical axis, it's much easier to control, but at least in the form of delivering power or generating power, horizontal axis gives a the edge out of from the vertical axis. So that is mostly rotor side converter and grid side converter, so bidirectional converters are used. So that is from the week's uh, overview. So entire week's overview, microgrid, DER integrated distribution systems, and the distribution system reconfiguration. So all these things are being discussed, and that summarizes the overview of the entire week. Now we'll switch on to the question answer session, and based on the assignments of the previous assignments last year as well as last year assignments that were being given in the portal. So we'll discuss one by one. So you can take 1 minute break and then we shall start. Okay. In the meantime, if you have any questions, you may ask. Otherwise, we'll wait for 1 minute and start discussing the assignment questions. And mostly the questions would be theoretical type because they were not, I have not found the numericals in this book. So let's clear with theory part of the current time. Okay, then let's start one by one. So, question one. So sectionalizing switches used in power distribution networks are of normally closed NC type, partially closed EC, or normally open, uh, and partially. So these are the four options. We select. We may write in the chat box. So sectionalizing switches are normally closed type. Moving on to the next question. tie switches used in the power distribution networks are of normally closed type, normally open type, partially closed type, or partially open type. So this is normally open type. The appropriate integration of a distributed generation unit into a distribution network reduces the energy loss of the network because it provides renewable energy, it supplies active power locally, it mitigates power quality problems, and it suppresses thermal loss. So we will supply active power locally. So the following can be set as constants to maximize distributed generation penetration to the distribution network. A radiality constant to power balance constant, C thermal limit of lines, and D all of these. So, so one thing, using an image, multiple options are here. So here, the options provide alpha for balance constant and thermal limit constant. The following objective function or functions is formulated for distribution system planning problem, but not for distribution system reconfiguration problem. So the objective function is this is also an MS skill sir. So, cost of nuclear routes, cost of substation expansion, cost of energy loss, and reliability maximization. These are the four options. So here these two are common. So this is also an MSQ question. Which of the following attributes are relevant to define DG? Types of the distributed generation unit, ratings of the distributed generation unit, purpose of DG, locations of DG. So this is an MSQ question, so multiple options being correct. DG will be defined as the ratio purpose of using the DG and the locations of the DG. So, generation. So this is also an MSQ. Generation unit is called the DG unit if it is located at transmission network over voltage. Sorry. So I also felt that these options are very incorrect. So I written next question. So generation unit is called a DG if it is located at transmission network, distribution network, customer side of the meter, external portion. This is also an MSQ. So DG can be considered with the if it is located in the distribution side as well as in the customer side. Right? So both the options are question number 3. Actually, high value of busy integration over and above the load demand of a distribution network causes loss of generation, overvoltage of the network, undervoltage in the network, high power loss. So this is also a resistive question. What are the possible causes of excessive high value of busy integration over and above the load demand of a distribution? Loss of generation may occur, overvoltage of the network, maybe seen undervoltage of the network, or high power losses. These two options are correct. Which of the following unit does not belong to the renewable distributed generation category? Wind, solar, small hydro, gas turbine. This is an ST question. India, gas turbine is the correct. Which of the following units are the major stakeholders in India mission of increasing share of renewable power generation? Small hydro, wind, solar photovoltaics, and gas turbine. This is an MSQ type question. So this is wind and solar photovoltaics. Which of the following forms of renewable energy holds maximum share in installed capacity in India? Wind, solar, small hydro, bioenergy. So maximum share is or percentage is almost 4. how does the implementation of DG contribute to grid resilience from the techno-economic perspective? By reducing energy losses, by reducing the need of grid maintenance, by providing backup power for grid outages, by decreasing the need of energy storage. This will by providing backup. Which of the following can typically be a range for power generation capacity of medium distributed generation? Medium means 5 kilowatt to 50 kilowatt, 5 megawatt to 5 kilowatt, 5 kilowatt to 60 gigawatt, or is 5 megawatt to 50 megawatt. Yes. So which one of the following are advantages of integrating routing and distribution network? Enhance reliability and input cost quality, reduce power flow in the distribution network or the distribution lines, reduce power flow in the distribution lines, reduce network power losses, or all of the above. So from this we may see that all are sufficiently delivering the are sufficiently are the advantages integrating the right. So all of these are so that's it from my side today. And if you have any questions you can ask. Otherwise, we are done for today's talk. We will meet on next this Thursday. We will extra class. We will meet next Thursday. This Thursday. So that's it.